Welcome to Ask and Learn.
Hey, it's Clarissa and Numerain. So here we have big O notation. So f of x is O of g of x. Is there exists constant c and k such that absolute value of f of x is less than or equal to c of absolute value of g of x whenever x is bigger than a. So we have a, and we have 17x plus 11 for f of x. So let's choose k equals 18. And we're going to use x is bigger than 18. And when we absolute value this, we get absolute value of 17x plus 11, which is less than or equal to 17x plus 11, which is equal to 17x plus 11, is less than or equal to 18x, which is less than x times x, and this is x squared, which is equal to the absolute value of x squared. So we need to choose c to be at least 1, so c is 1, and we see that this is a big O notation with k equals 18 and c equals 1. For part B, we have x squared plus 1000. Let's just choose k equals 100, so we'll use x is bigger than 100. So we know that since x is bigger than 100, x squared is going to be bigger than 10,000. So we take the absolute value like we did in part A, and we get x squared plus 1000 is smaller or equal to the absolute value of x squared plus 1000. And this is equal to x squared plus 1000 less than x squared plus x squared, and that becomes 2 of absolute value of x squared. So we could take c equals 2, and this is a big O notation with k equals 100 and c equals 2. For part C, we have x of log of x. We take the absolute value of f of x, and this is the absolute value of our equation, x log of x is less than or equal to the absolute value of x times x, which is just equal to x squared. So if we take c equals 1, then this is a big O notation with k equals 0 and c equals 1. For part D, we're given f of x is equal to x squared, x to the fourth, over 2. For large values of x, the fourth power of x is much larger than x itself. So the larger value of x, the larger the constant c needs to be. So the inequality of the absolute value holds true. So we can't find a value of c that holds for all values of x. So this is not a big O notation. For part E, we're given f of x is equal to x to the 2 to the x. So we have f of x is equal to absolute value of 2 to the x, which is equal to 2 to the x is less than or equal to cx squared, which is equal to c absolute value of x squared when solving for x is bigger than k. So when we solve this, we get c is bigger or equal to 2 to the k over x squared. And we're going to determine the limit for increasing values of x, and we get c is bigger or equal to plus or minus infinity. So we see that this is not O of x squared. For part F, we have a ceiling and floor function. So we take the absolute value and we get less than or equal to x times x plus 1, which is equal to x squared plus x is less than or equal to x squared plus x squared, which is equal to 2x squared, and this can be 2 absolute value of x squared. So we need to choose a value of c to be at least 2. So c is 2, and by the definition of big O notation, k is 1 and c is 2.